All right, on the back, we're matching or classifying. We have three choices: exponential, linear, or quadratic. This graph is flat on this side, and then it's increasing. So those graphs that are flat on one side are exponential. This graph is a straight line. Remember, the word line is in the word linear. So this graph is linear. This graph turns around at one point, and that is quadratic. Remember, quadratics look like U's. Okay, quadratics either look like U's or upside down U's. Right? Exponentials can look like this. They can look like this. Or they can be flipped upside down and look like that. Or like that. Lines, straight lines. So straight line that's horizontal, positive slope, negative slope. All right, next one. It's an equation. Notice where the x is. The x is in the exponent, so this is exponential. For the next one, the highest exponent that we see is a 2, so that makes this quadratic. And for this one, the highest exponent on x, remember, it's not written, but it's there. It's a 1, so that makes it linear. Right, we got some tables to look at. In this table, if we try to see what's happening down the y column, here it looks like I'm adding 10, but here I'm adding 20, and here I'm adding 40. So I'm not adding the same amount each time. Okay, if I try to see if I'm multiplying, here I multiply by 2, I multiply by 2, I multiply by 2. So if every single time I'm saying times 2, if you're multiplying by the same number all the way down the column, it's going to be exponential. Right, for the next one, I subtract 9, I subtract 3, and then I add 3. Okay, so it's not adding or subtracting the same number. If I tried to get 13 and figure out how to get to 4 with dividing, it's not going to be the same number to get me back to 4, and then I get bigger. So I'm getting smaller, and then I'm getting bigger. That tells me my graph is turning around. Okay, so if my graph was getting smaller, and then it turns around and gets bigger, it's got to be like this quadratic. Okay, another way we talked about figuring it out is looking at the difference. So this went down by 9, this went down by 3, and then this went up by 3. And then we said we could take the difference again. So the difference here is it's up by 6, and then here is up by 6. And these second differences matched, so that's quadratic. All right, number 13. We're going down by 10, down by 10, down by 10. So every single time I subtracted 10. Remember, if you add or subtract the same number every time, it's going to be linear. Hourly rate of pay increases by $1.50 each year. So it's increasing by the same amount for every unit. So when it's a constant increase like that, this is going to be linear. The population of a species of insects is declining by half every year. If you take half of something, you're multiplying by 1/2. If the change is that you're multiplying by the same number every time, it's exponential. Remember, we talked about keywords like taking half of something, doubling something, tripling something. Those are keywords for exponential. The equation that models the height y of a toy rocket that is launched in the air after x seconds. When we're launching something in the air or kicking a ball, that thing is going up and it's coming back down. It's going to change direction like that. This is going to be quadratic.